In this video, we're going to take the information we have from this problem and use it to create a contingency table. Our goal is to be able to detect how many false positives we're getting or false negatives we're getting, and basically deduce a little bit more information from the data given here. To do this, we need to realize in the very beginning that we have a 3x3 contingency table, and the reason for that is we have two variables. I'll go ahead and put HIV status on the top, and then test result on the side. Now, when I look at HIV, we can say, well, you have it or you don't. And I'll write that as HIV or HIV complement. Then for a test result, you can either get a positive or a negative. We have this extra row and this extra column because we need our totals. So we'll have a total here and a total there. Now, we've talked about this before, but the thing to realize here is I don't have a sample size. And because I don't have a sample size, there's two ways to do this contingency table. One is to fill it in with probabilities. To do that, I would put a 1 in the bottom right-hand corner here, and everything would involve decimal places. Now, because that can be a little bit tricky keeping all those decimal places, instead, I'm going to go ahead and make up a sample size of 100,000 people, and I'm choosing 100,000 because it's a nice round number. You could choose 10 if you want, or like 71, a nice big round number that is going to help us avoid those decimal places. Now I've got that, I'm going to go ahead and start filling out my table. To do that, I look back at what's given to me, and I know from up here, the sensitivity is 95.62, the specificity is 97.12%, and there's one other little piece of information I have up here. And that is at the very top, it tells me 0.3% of the population actually has HIV. So, from my table, I know I'm dealing with 100,000 people. And what that top tells me is 0.3% of those 100,000 people will have HIV. So what I need to do is take 0.3% of 100,000. To do that, I'm going to take 100,000 multiplied by, and 0.3% as a decimal is 0.003. So once again, that's 0.3%, and we divide it by 100 to convert it to the decimal place, so 0.003. Multiplying these together then, I get a total of 300 people out of my 100,000 would actually have HIV. Once I get that number, it's fairly easy to go ahead and fill in the number who don't have HIV, right? As their complements, I'll just take the 100,000, subtract off the 300, and when I do that, I get 99700. So that'll be the number without HIV. Once again, to do this, I use that first piece of information there, that 0.3% of the population has HIV. Now I've got the totals filled in that row. I can go ahead and use my sensitivity and specificity. Let's talk about sensitivity first. Sensitivity tells me out of everyone who has HIV, 95.62% will get a positive test result. Based on this then, I can tell that in my sample, I had 300 people who actually had HIV, right? And out of that 300, 95.62% of them should get positive. So I'll take the 300 times 0.59562. Or, once I've done this here, once again, out of the HIV, I have 95.62%, or 286.86. Now notice I'm keeping the decimal place there, even though technically it doesn't make sense for me to have 0.86 of a person. And the reason I'm keeping that decimal is I made up my sample size. I could have chosen a larger sample and avoided those decimals, but I didn't. So I'm going to keep that accuracy. And once again, that's because I got to make up the sample size. Once I have the fact that 286.86 of my 300 people would get a positive, I can go ahead and use subtraction to fill in the next blank here. So that is, I know I have 300 people in total, so I'll take 300 minus 286.86 to get 13.14. And that'll be the number right here who have HIV and get a negative test result. So now I've got the HIV column filled in. It's time to look at the complement of that. And to do that, we need to look at our specificity. Specificity tells me out of the people who do not have HIV, that's HIV complement, 97.12% will actually get a negative. So I know from my problem that there are 99,700 people in my made-up sample who don't have HIV. So I need to go ahead and find 97.12% of that, or 0.9712. I'll do that by multiplying those two numbers together. And what I get out is 96828.64. Once again, keeping the accuracy because I got to make up my sample size. So, having this number right here, I need to think really hard about what this is actually telling me. It's saying that out of the 99,700 people who don't have HIV, this is the number who are going to get a negative, because that's what specificity measures. So I'm going to go ahead and come up here and add this into the HIV complement negative cell. To get my remaining cells here, I can go ahead and use the additive properties of a contingency table. That is, I know this column has to add to 99700. I know the rows have to add across. So go ahead, pause the video, and fill them in. So once we've gone ahead and filled in our contingency table, it's always a good idea to check to make sure our numbers are actually working out. And the way to do that is to check that they're all additive. That is, all your columns should add down, all your rows should add across. So for instance, when I take the number who had a positive test total and add it to the number who had a negative test total, I should get 100,000 overall, which in fact it does, telling me that I've done something correct. I can check every row and column if I want, just to make sure accuracy. Now that I've got my contingency table filled in, it's time to go ahead and use this to make some inferences about what percentage of false positives or false negatives we're getting on this very specific HIV rapid screening test.